Question. If two positive integers a and b can be written as a is equal to x cube y square and b is equal to x into y cube, where x and y are prime numbers, then HCF of a comma b is option A x into y, option B x into y square, option C x cube into y cube, option D x square into y square. We can just apply the definition of HCF. Where HCF is found by taking the smallest power of each prime factor in both the numbers. Now we are given that a is equal to x cube into y square and b is equal to x into y cube, where x and y are prime numbers, which means a and b are written in their prime factor notation. Now let us write a table for powers of x and y in a comma b. Power of x, power of y. In the columns we have a and b. Now the power of x in a is equal to x cube y square is 3. Similarly, the power of x in b is equal to x into y cube is 1. The power of y in a is equal to x cube into y square is 2. Similarly, the power of y in b is equal to x into y cube is 3. Now to find the HCF, we need to find the minimum powers of x and y. The minimum power of x in a and b is minimum of 3 comma 1, which is equal to 1. The minimum power of y in both a and b is minimum of 2 comma 3, which is equal to 2. Therefore HCF is equal to x to the power of minimum power of x into y to the power of minimum power of y, which is x to the power of 1 into y to the power of 2, which is x into y square. Therefore HCF of x cube into y square comma x into y cube is equal to x into y square, where x and y are prime numbers. From the given options, option B is the right answer. Therefore, if two positive integers a and b can be written as a is equal to x cube into y square and b is equal to x into y cube, where x and y are prime numbers, then HCF of a comma b is x into y square.